Aluminum nitride. Aluminum, of course, is Al. And what's its charge? 3 plus. And what about nitride? N and it's 3 minus. Do we bring down the 3's at all? Because they would cancel out. That leaves us with just ALN. Raise your hand if you got ALN as the answer. Okay. Calcium sulfide. Calcium is Ca, and it's 2 plus, correct? Sulfide is S, and it is 2 minus. You do crisscross on this, and you just get CaS. Good. Magnesium nitride. Mg, of course, is 2 plus. Nitride is N, and it's 3 minus. You bring these numbers down, and you get Mg3 N2. We get that right? Okay. Iron 3 oxide. What does that 3 mean from our notes? The charge of oxygen or iron? So Fe is 3 plus, and O is 2 minus. You bring your numbers down, and you get Fe2O3. Cobalt, CO2 plus. Sulfide, S2 minus. You bring down these numbers and they cancel each other out, leaving us with COS. Or potassium nitride, K is 1 plus and N is 3 minus. You bring down those numbers and you get K3N. What do we think? Good? Now we could go reversal on this, which isn't too bad. Now let's give the name. There's ALP, Na2S, Ca3N2, FeO, CO2S3, and KF. Write down these formulas real quick, and then let's give the names of them, going backwards. On this first one, you have ALP, so you would just simply name this aluminum phosphide. Would you put the prefix mon in there? Because the prefixes were for covalent compounds. Is this covalent? No, we're on the ionic compound list. You know this would be an I because of the Al. Now you know why I kept pushing that we can see the differences quickly between them. Because there are no prefixes with ionic compounds. How about Na2S? This would be what? Don't use, there's no disodium at all. No prefixes, just said that. Sodium sulfide. Did you see a prefix at all? Because this is guaranteed to be an ionic compound. Ca3N2. Calcium nitride. Did I use prefixes at all? Nope, because this is an ionic compound. I know that because I've got a metal in it. Now, and watch closely on this one. This is a hard concept to teach, one of the most difficult concepts with naming compounds. People would name this iron oxide. Is that what you named it as? You need the charge in there because it's a transition metal. Now watch closely. How many oxygens do you see? There's only one oxygen, right? What's the charge of oxygen? 2 minus. Since there's only one oxygen, that means that there's a total of a -2 charge from our one oxygen. How many irons are there? Irons? There's only one iron. I didn't put a number after the iron. So what charge does it have to be to counterbalance that 2 minus from oxygen? It's going to be a 2 plus. And that would make sense. See, if you do cross of 2 and 2, that's where you get 1 and 1 from. So this would be iron 2 oxide. Raise your hand if you put iron 2 oxide as the answer. Very good. Very good. Cobalt sulfide. But what's so different about cobalt? It is a transition metal. What's the charge of sulfur? It's a 2 minus, right? That's where that 2's coming from. So what does that mean the 3's coming from? The cobalt. That means the cobalt has to be 3 charge. How come I didn't do the parentheses with the number inside of it for aluminum, sodium, or calcium? They're not transition metals. Potassium, is it a transition metal? No, so we don't need to use our parentheses. Potassium fluoride. What do we think? Good? So this would be naming simple ionic compounds, what we call binary ionic compounds, because they only have metals and nonmetals in them. Nothing more. Good? Question?
What do you call the metals that are like
Those are still like, they're very, very weak metals. But you wouldn't call them transition at all. Well, except for some of them. Like tin and lead, Sn and Pb, they're both transition metals. So is antimony, which is Sb, if you wanted to write that down.